Our next speaker is Szabolcs Csepregi, and he is the director of search technologies. You can also call him Sabi, I guess. And he's going to talk about Markush. Markush is a great new feature, a fairly new feature, to the JChem base and the suite of tools that we've got.
Thank you. Can you hear me well? Okay. Miklos almost started the day, well, he was the second presenter, with an area which has gained lots of development recently. And now I'm almost finishing the day. I'm the last, I'm the one before the last presenter. I'm almost finishing the day. Another area where we are very active in the development and very excited. We have started this Markush development around 3 years ago, where our main goal was to extend the ChemAxon capabilities, which covered the molecule and reaction areas, into the generic domain of Markush structures. I will show now what we have achieved during these 3 years, and what are the immediate plans to go further. So first of all, I will cover what are these Markush structures, and actually where can we get them? Where can they come from? And I will see a little bit about what you can already do with Markush structures at ChemAxon, and as I mentioned at the end, I will cover the new things. So, what are these Markush structures, and where are they? Oh, sorry. So Markush structures are generic notations. Notation of chemical structures, which describe not just one specific compound, but a class of compounds, many compounds in a compact form. They are mainly used in two areas. One area is combinatorial chemistry, where a combinatorial library can be described in a concise manner. And another main usage area is chemical patents, where a patent claim usually describes a class of compounds, where a pharmaceutical company usually claims a set of the chemical universe for a certain purpose. These are the current features of these generic notations, which are available at ChemAxon products. So we have R groups here. One example is like this one here, or this R2, and these are the definitions of these R groups. We have atom lists and bond lists. Atom lists are like here, where at this position there can be a carbon, nitrogen, or an oxygen. And bond list is something like here, which means that this denotes a single or a double bond here. Position variation bond means that, for example, this bond here can attach to these highlighted atoms, either here or there. We also have link nodes, which means for example, this atom here can repeat 1 to 3 times, so actually it may be a larger chain here. A generalization of link nodes are the repeating units, which can be seen here. So this is a larger group which can repeat 2 times or 4 to 6 times. And finally, we have the homology groups, which are very popular in patent documents. This is a description of a well-known chemical classes. for example, an alkyl group or an aryl group, and so on. Okay. Now we know what Markush structures are. Where can we get them? Well, we've got the nice structure editor Marvin Sketch. It contains many features to sketch them. But there are many goodies like zooming controls. We can zoom to the scaffold, or R group definitions as well. We've got nice controls to add position variation bonds and so on. And in the upcoming 5.3 version, we are implementing a new import module which will be able to read Markush structures from the patent literature. Markush structures can...
Can you talk a little bit more about, I don't really get to that. Can you?
The VMN.
The stuff that you're going to get from the patent literature, what does that mean?
It means that we are implementing a format which is used by the Derwent Markush database, Derwent Patent Index, so that structures, Markush structures curated by Thomson Scientific will be able to load it into Marvin Sketch or into JChem.
Are you flexible on that? Because that's not the only format.
We are very flexible, and we are eager to work with content providers to be able to recognize other formats as well. Okay, Markush structures can also come from the combinatorial chemistry area. So if we have a file of reagents, we provide a little tool for reagent clipping, so that the reacting group can be removed, and we can put together a Markush structures where the R group definition comes from these clipped reagents. It may not be very familiar for everyone, but those involved in combinatorial chemistry, they know this problem very well. Another area where Markush structures can come from is R group decomposition, where a scaffold search in a database can retrieve specific molecules, and then these molecules can be cut into this R group table, and this R table can be then converted into a Markush structure, which represents this R table. Okay, what can we do with them? During these years, we have developed a nice Markush Enumeration plugin, which is available from various interfaces, like any other calculator plugin at ChemAxon. With this plugin, we can sequentially or fully enumerate Markush structures, or we can select some parts of the Markush structure and browse that area. We also provide random enumeration, because very often, especially the patent Markush structures, are so complex so that it would take years to fully enumerate the whole library. But a random enumeration can give a quick preview of the chemistry space which is contained in this or described by this Markush structure. During this enumeration, we can color and align the enumerated structures according to the original Markush structure, so that it is easy to see which comes from where. And so here on this picture, the red areas come from the scaffold, and the different colors come from different R groups. And the orientation is the same as well. Regarding the homology groups, we can optionally enumerate them, and for this enumeration we provide a library of example definitions which can be customized by the user. These Markush structures can also be imported into Markush tables in JChem base or in instant JChem, and we can search them. When we are searching in a Markush table, the searching behaves like as we were searching in the enumerated space of these Markush structures. But actually, no full enumeration is being performed. We had to find ways to avoid that because, as I mentioned, it may not be feasible for these very complex Markush structures. Okay. We have substructure and full structure search on these tables. When it comes to substructure searching, it's not very easy to see the substructure hits within Markush structures. So this is a nice example. We've got a substructure which we want to find in a Markush library, and we can see the matching parts highlighted here. So you can see that, okay, that area there is somewhere here. Okay, that area is over there, and that side chain goes into R21, which is over there. It's not easy to relate which one belongs to there. So we can reduce this Markush record in a way that we can expand those variables which overlap with our query. And as a result, we get a reduced Markush structure, which is much simpler, which was our original Markush structure. And we can see the query as a whole, so it's very easy to relate this reduced Markush structure to our query. Is this clear what's going on here? Okay, good. And now let me show a demo. First of all, I'm opening up Marvin's sketch. Yeah, this is a Markush structure. First of all, I show the zooming controls. So this is the scaffold. I can zoom to R1 definitions, R20 definitions, and so on. And you can find the enumeration plugin amongst the other calculation plugins. I can see what the library size is. It's a 10 to the 9th library, which is quite big. Nevertheless, I can start a sequential enumeration. So these are the actual structures contained within this library. And the enumeration is going on and on. Okay, stop it now. Well, we can do some random enumeration to quickly browse the chemistry space. Okay, here. And here we can see that these homology groups are also have some example definitions here, like this cycloalkyl is expanded into this cyclohexane ring. Okay, we can also select just part of the Markush structure. Let's say that I want only to expand these areas. Okay, and only those variables are expanded. So I can select that so that this enumerated structure goes back into the Marvin sketch. I can browse further so that I enumerate these further. And maybe I've got those. Okay. Let me switch over to the development version. It is the upcoming 5.3 version, and I'm loading. Actually, I already have a Markush structure coming from the Derwent patent database. Here we can see that, for example, the homology groups have a different name in the Derwent database, we can also recognize these shorter names. They are just aliases in our system to the longer, more explanatory homology names. So CHK actually means the same as alkyl here. Okay, it's not very well drawn, this structure. Let me just call a 2D cleaning on it. So, okay, here we go. This is what Marvin created from it. Okay, so we have all different other homology atoms there, aryl group and so on. So let me have a quick enumeration of this patent Markush structure. Oh dear, it's not working. It was working just. Let me open it again. Okay. Sorry, I won't be able to enumerate this. Oh, I know. For some reason, I think the homology enumeration does not work for this in one step. Okay, but anyway, we can enumerate it without the homology groups. Now let me try to do the selective enumeration for that. So, okay, it's working this time. Okay, so what we did, I loaded a Markush structure from the patent literature, and I was able to enumerate it finally. I promise that in 5.3 we will fix this, so you will be able to fully enumerate straight away. Okay, let me show some searching, some database stuff. Again, I'm going to use the Java server pages example, which I used yesterday. And we have a Markush table here, which contains several Markush records. By default, only the Markush the scaffolds are displayed, but I can switch on the R group definitions as well, but it's not that easy to see. Okay. Let me just first show some enumeration. Markush enumeration is also integrated into this example. Let me just copy the first enumerated structure and query that one. Okay, we've got this. We are running a full structure search. Hey, we indeed have found this structure, this Markush record, and we can also do a substructure search.
Can you do similarity against Markush?
No, it's not available yet. We are not really planning similarity in the near future, but we are planning a kind of maximum common substructure search against Markush targets. So it means that given a specific molecule which is not covered by the Markush structure, we want to show what is the closest match to this compound to the Markush. So by an MCS-like manner. Okay, so this is the substructure we found. So let me show this Markush reduction here. Okay, in this case, it is not that exciting because it's only the atom list which is expanded. So let me draw a different query. This should be in in several records. There we go. Okay. For example, we have this structure, and actually there may be more than one places where this substructure can be found in the Markush structure, and we can show each of them. So there are different substituents which contains the same substructure. Okay. That's for the demo. Oh, by the way, there is a third program which also contains Markush, this Markush capability, is InstantJChem. So it is also possible to create Markush tables in InstantJChem and do the same kind of searching and some basic enumeration as in the Java server pages example. And I'm just showing a nice form which I created with InstantJChem, and in this form I could put up the scaffold without the R groups and another version of the Markush structure which contains the R group definitions as well. Okay, back to the presentation. What's new? In 5.1, we just released these. 5.2, we just released these homology groups, which are available in the template library. As I mentioned, that for the enumeration, the definition of these homology groups are customizable, and it is also possible to add custom homology groups by these definition lists. But actually, for the searching, we rather use an algorithm to identify what are the alkyl groups and what are the heteroaromatic groups. In that case, we won't just find those structures or those groups which are listed in the homology definitions. Okay. Earlier we've seen that these reagent files can be read as a definition. So this is a new feature as well. And these position variation and repeating units are quite recent features as well. Oh, and one comment is that all of these Markush features are also available in queries against molecule tables. Currently, we are not doing Markush searching, but it's in the pipeline. Okay, what's under development? As I mentioned, we are working on this VMN file format import, which is the file format for the Derwent Word Patent Index. We are working on homology variation queries, which will be available in 5.3 against molecule tables. But later, these will be available for Markush tables as well. Okay. In the 5.3 version, not all the features of these VMN files could be grabbed. The major features will be handled, but some minor things, something like when for the homology groups, there may be some properties like a lower alkyl, which means that the alkyl only can contain carbons from 1 to 4. Now, this property, this lower, this won't be handled in the 5.3, but we will cover that in a later version. As I mentioned, we want to do a maximum common substructure type of searching to be able to identify those patent Markush structures which almost cover the query molecule, but not quite. Okay, and as a next step will be an overlap analysis of Markush structures, so that on the query side, a Markush can be specified and see what are the Markush structures in the database which have some overlap. And we are looking for a way to show what actually that overlap may be. And at the And the end, we are also want to introduce some conditions for Markush variables. For example, if R1 is hydrogen, then R2 can only be these and these and these definitions, and not those. As a summary, we have seen the Markush structure capabilities at ChemAxon, which is now reaching actually the patent space. So you have seen that we could really enumerate the patent Markush structures from the Derwent Patent Index. And it is a work in progress. There is we have lots to do still, but I think it is already useful. I would like to thank my colleagues who helped in this project, and I would like to thank Tim Miller and Linda Clark at Thomson Reuters for providing some help and example files from the Derwent Patent Index. And I would like to thank many of the early adopters and colleagues in the field who gave us very useful feedback for this Markush project. And many of them are present here as well. And I would like to thank your attention, and I'm ready for your questions.
Great. Questions? All right.
Pardon me. You showed how you can search for a member of a Markush structure, class, or family. Can you also search, say you've built a database of Markush structures, can you actually search for the Markush structure itself to say, is this class
yes.
in my... So you
yes,
can draw
there is a duplicate search, yes. Yes, it actually... it is when the Markush library is described in a different way, then it will not find. It will only find the duplicates where it is drawn exactly the same way. So it's a really duplicate searching.
And I guess one other comment would be just in case people aren't aware, which we discussed, is that if you have an any table and you put a Markush structure in it, it's not actually going to be treated as a Markush structure. That's just something to be aware of.
No.
It needs to be actually created as a
No, it will be treated
Markush.
as a fragment, as a collection of fragments. You need to create Markush tables to allow this capability.
I'm just wondering about the state of the art with regard to formats. You mentioned the VMN format, and I wonder if that is a satisfactory format from your viewpoint on what your plans are. Does it support the features that you plan, like conditional substituents? And are you going to be able to export it? Do you see there being a format that you recommend for information exchange?
Right. Actually, VMN is not the only format which can capture Markush structures, but for example, mol files can represent R group structures, and then the Marvin format can also represent all these features. The VMN is relevant because Thomson Reuters has a large collection of patent Markush structures. So it allows us to access Markush data. And it allows our customers to be able to analyze the patent literature with these tools. There are many other file formats as well, most of them proprietary, which are used in this patent area. And we are eager to work with companies like CAS and Questa to be able to handle their content as well. And maybe it's something we may do something together.
Any other questions?
And we talked yesterday briefly about kind of stereochemistry in the Markush, but is that even supported in Markush kind of notation?
It is supported. Yeah.
Okay.
There may be some cheesy things when, for example, the stereochemistry is next to a connection point. If there are more than one connection points involved, or no, actually when the stereocenter is next to a connection point, then it cannot be handled currently. But we have plans to introduce an explicit connection point with actual coordinates, and with that it will be possible to express this kind of stereochemistry.
And one other question, unrelated, but in terms of, so for the R groups, you were saying you could have them in an external file. Is that true?
No. It is contained in the same file, in one record, but there is a possibility to load an external file and turn them into R group definitions.
Okay.
In one,
so like
in one record.
Into the R group. Very good.
Actually, I have a question to Pat. You mentioned similarity search against Markush. Do you think the MCS is a solution for that?
Not necessarily, because I mean, a lot of times I might just say, okay, I have this molecule that I'm interested in. Can you show me patents that I want to look at? And a lot of times what I'm looking for is just patents that contain similar molecules. I mean, the MCS is definitely going to get you closer to your frequent operator. But sometimes I'm just working and I say, okay, I'm working in this series, and maybe I'm working with, a certain heterocycle, and I want to see that heterocycle plus related heterocycles.
Okay.
I'm interested in the Markush for combinatorial libraries. And sometimes part of the design is to say, okay, let's search that library for things with physical properties so that nothing has a log P greater than 4 or too high a molecular weight or something like that. Is that possible within your searching now to search these kind of additive properties?
It is not directly possible. What can be done is that it is possible to do a random enumeration of the library to get some sampling of the chemistry space. And those randomly enumerated structures, for them you can calculate the properties so then you've got some property profile for the library. That is what is available at the moment.
But if you have properties that are directly additive, you can actually be exact about it. I mean, John Barnard published some stuff about that.
Yeah, that's true.
7 or 8 years ago.
That's true, but it does not seem to be the mostly requested feature. So we are not going at that direction now.
Okay. Are there any other questions? Great. Thank you, Szabolcs. Let's give him a round of applause.